Everyone, welcome back to my channel. So today in this session we are moving on to the next lesson in your physics part. So that is first lesson in your part 2 textbook, that is light, reflection and refraction, that is class 10th. Okay, so in this lesson I have made 3 sections. The first part is related to the concepts which are related to this lesson. Second part is about ray diagrams, means completely it is related to ray diagrams, how to write the ray diagrams and how to understand how the images are formed in ray diagrams. The third part is numerical problems related to this lesson. So how many sections? 3 sections. One are the concepts, that means theory, you can say it as theory. Number 2 it is ray diagrams. Number 3 problems. So in this session I am going to discuss about the theory part, that is concepts which are related to this lesson. In my next sessions I am going to discuss about the ray diagrams as well as numerical problems. So let us begin the session. So in this session, before going to know about the light, so to relate it to 10th standard syllabus, let us understand some basic concepts about the light. So firstly, what we are going to talk about a light, how you define a light. So first, generally what we say that what is light means, what we'll say, light is a form of energy. Yes, right? Yes, definitely. What we say that light is a form of energy, we say it. The first statement itself, light is a form of energy. How it helps us? It helps us to see objects. So light is a form of energy which helps us to see object. This is the very basic concepts that you learned from your lower classes. Okay, how it will help us to see object, what is the main steps it undergoes means, you can observe this figure here. What is happening? The light is falling on this flower. Yes, right, the light is falling on this flower and that light is reflecting back. That light is reflecting back through our eyes, near to our eyes, then it reaches our eyes and then we are conclude it is a flower. Right, that's what we are concluding. When light falls on object, it reflects the light. When the reflected light reaches our eyes, then we see the object. This is what the main steps that undergo how we see the objects. So first light falls on the object, that light it will reflect back from the object. Okay, and it reaches our eyes, then only we can see the object. Okay, the first step is light is a form of energy which helps us to see object. How it will helps? First, light falls on the object. After falling that light, it reflects back and that light it reaches our eyes, then we see the object. Okay, all these are basic concepts once we are recalling all this. Next important one of the property of light is light travels in straight line. Yes, this is very important that you have to remember, and this you learnt in your 8th standard also, one of the basic concept, that is light travels in straight line. Here in this both the situation you can observe. Here we have like a square board which is fitted 3 squares and one light, and for each square cardboard there is one hole, right, one hole, and through, if you keep it in a straight only, we can observe this candle. Okay, light of this candle. If you keep one above the other like this, we cannot see. That means what we can conclude is when we are seeing an object, light should always travel in a straight line. Or if you come to this situation, here the person is able to see this candle. Here he took a cylindrical cardboard, you can cardboard or rod, something else. So it is like a straight, right? So here a person able to see the candle, light of this candle. But in this situation, this rod or cardboard is bent, right, little bit blocked. So at that time the light is blocked here itself. It will not travel further. Okay, some you can see that light is on, but you cannot see the whole candle like this, light like this. So what we can conclude from these two situations is here the person cannot able to see the light of candle. So from this situation, here what we can say, light travels in a straight line. Okay, this is also one of the basic concept. If we move on to the next one, from this light means in this lesson particularly, if we come to this lesson, the common phenomena of light, common phenomena of light means formation of shadows. Yes, right? If light falls on you, so due to you are opaque, so the light, you form shadows. Next, if you observe like this, right? So this is light, opaque, hand, shadow. So yes, the common phenomenon one is a formation of shadows that you learnt in lower classes. Now we are not recalling it, just I am talking about what are the main phenomena that we learned. Next, formation of image of mirrors. Yes, reflection. Yes, right, you can see the reflection of an object through mirrors. And bending of light through a medium. Yes, right, bending. I think this are you all came into. Yes, right, instance this. Yes, if you keep any straw or a spoon in a glass of water, you feels like a spoon, or this what we can see the straw, it seems like a bending, right? So it is not really it's bending, it seems like though. So we can call it as refraction of light. So in particularly in this lesson we are talking about reflection and refraction. I think it's clear about this lesson. So now we learned what is the light and how we can see the object and how the light travels and what are the important phenomena in the light. So in this lesson basically we are understanding about the reflection of light, that is about mirrors, types of mirrors and how the images are formed in the, that means ray diagrams, and refraction and types of lenses, okay, in that lenses, and how the images are formed in that lesson. So let us begin. So first is reflection of light. What do you mean by reflection of light? So what is reflection of light means? Here you can see the mirror. Usually the reflection means what is the main object we are considering it as? Yes, mirror. So what we can say, when a light falls on highly polished surface like a mirror. See, this is what you have to understand. Here highly polished means one side should be, and you can observe, you see the reflection of light in the glass. If you consider a glass, and if you see you can see the reflection of light in the glass, only the glass piece. No, that means here it's in both the sides it is not polished, but you can observe the one side of the mirror will be polished. So that's what we are saying, when a light falls on highly polished surface like a mirror, most of the light is sent back into the same medium. Yes, most of the light is sent back. So this process we are calling it as reflection of light. Here you can see that light is falling on the mirror at point P and it is reflecting back. Yes, right. So here we have the part here. So the light which is striking the mirror, we are calling it as incident ray. Remember. Then as soon as it is striking on point P and it goes back, it's sent back, that ray we are calling it as reflected ray. So this is the ray which strikes the mirror, we call it as incident ray. It goes back, we are calling it as reflected ray. Between that we have one common point that is called as normal line. I think it's clear. So in this we can observe incident ray, that means which is striking the mirror, and which goes back, the ray which goes back we are calling it as reflected ray. In between them we have a line called as normal line. And if you consider this normal line, here you can observe the two angles. Yes, right, two angles, angle I and angle R. So what we are going to call, I is called as angle of incidence. Angle of incidence we are calling it as angle of incidence, that is which is that angle I. So here if we consider angle I is called as angle of incidence because it is an angle between the incident ray and the normal line, this one. Okay, this R we call it as angle of reflection. This is angle of reflection. So here we have the ray which is striking the mirror, we are calling it as incident ray. The ray which is going back is called as reflected ray. In between them we have a common point or common line, we are calling it as normal. So in between them we can observe two angles. One is angle of incidence, another one is angle of reflection. So I is called as angle of incidence, R is called as angle of reflection. This angle of incidence will form in between incident ray and the normal line. Okay, this angle of reflection will form in between the normal line and reflected ray. Okay, it's clear about reflection of light. If you move on to the next one, here we can observe two important laws of reflection. Two important laws of reflection that this also you learnt in your 8th standard, I think. So I'm recalling, this is also very important. So if we come to the laws of reflection of light, the first thing is, just now we spoke about angle of incidence and angle of reflection, right? And remember, these two are always equal. That means angle of incidence is equal to angle of reflection. This is the first important law of the reflection. The angle of incidence is equal to angle of reflection. That means angle I is equal to angle R. So incident ray, reflected ray, between them we have I and R. The both are equal. This is the first law. Second law, if you come across second law, here if you can observe, you have a mirror. You can observe the incident ray, right? You can observe the reflected ray, right? In between them we have normal. That means they are all on the same places, right? So what we can say, the incident ray, reflected ray and the normal line to the mirror at the point of incidence all lie on the same plane. Same plane, as we talk about like collinear points like that, right? In mathematics, collinear, non-collinear, that means they're in a straight line, not like that, or coplanar points like that. So in the same case here, what we can see, all these three lines, that means incident ray, reflected ray and the normal line, all are on the same plane. Both laws are very easy. The first law is nothing but angle of incidence is equal to angle of reflection. Second law, just take the three rays, that is incident ray, reflected ray and the normal line, all lies on the same plane. Very easy. If you understand these two, it is very easy to remember. Okay, these are the two laws of light. Next one, particularly if we talk about a reflection, it is related to mirrors only. Mirrors. This is related to mirrors. So here particularly we are talking about spherical mirrors. Spherical mirrors means a spherical mirror is a curved mirror which is a part of hollow sphere. For example, look here, if I consider a sphere, I think you all know about the sphere. Yes, right? Sphere. So it is a three-dimensional figure. So sphere, if we consider a sphere, if we take a curved part, only if I consider, look here, if I consider this part, only this part, if I consider like this or this side, any one of the part, this we are calling it as a spherical mirror. Spherical mirrors. Okay, again I am repeating, spherical mirror is a curved mirror which is a part of hollow sphere. Okay, so this is about the spherical mirrors. In the spherical mirrors, you have two types. One is, in that first one is concave mirror. The first one is concave mirror. So look here, this is the concave mirror will be like this shape. Okay, a spherical mirror whose reflecting surface, this is mirror, a spherical mirror whose reflecting surface is curved inwards. So this is curved inwards like this. Okay, curved inwards this is. Okay, so again I am repeating, concave mirror, a spherical mirror whose reflecting surface is curved inwards. This is the first type of spherical mirror. Second one is convex mirror. A spherical mirror whose reflecting surface is curved outwards. Sorry, this one is outwards. Make it outwards. Curved outwards. Make it as outwards. So a spherical mirror whose reflecting surface is curved outwards. So here you can observe this is a reflecting surface. And these lines, you may ask, what are these lines means it is polished one side, means this lines indicates it is polished. Okay. And these two can be observed clearly in the spoon. Okay, by the spoon here, if you consider a spoon, look here, the image is outer side. Look here, it is like the spoon. It is, you have turned like, yes, right, outside side it is. This is inner side. So this inner side is concave. Outer side is convex. Remember, that's what we are comparing these two shapes with the spoon. So here if you consider like this, so here if you consider like this, it is outward face of the spoon. So this acts as a convex mirror, this mirror. So it is inward. So inward acts as a concave mirror. So this is about two types of mirror. One is concave mirror, another one is convex mirror. In concave mirror, what you can conclude? It is curved inwards. How it is? Curved inwards. So convex mirror is curved outwards. Okay, make it as outwards. Clear? So let's move on to the next concept. Yes, now particularly if we come to the mirrors, like it may be concave mirror or it may be convex mirror. So in this we have some terms to understand. Number one is pole of the mirror. The first one we are calling it as pole of the mirror. Means if we consider a mirror, in that we have some terms or positions. So in that we calling it as pole of the mirror. What is this pole? Means it is a center of spherical mirror. Look here, if I consider a mirror like this, which type of mirror it is? Curved inwards, means it is concave. So the mid part, so center of the spherical mirror, or if I consider like this convex mirror, so the center part of this spherical mirror we are calling it as pole of the mirror. I think clear, right? So next one is center of curvature. So before going to center, what do you mean by center related to maths? What we call it a center point. So it is a mid of the circle, right? Maybe consider the midpoint of a circle, right? So here also what we are calling it as, for example, there, as they said, it is a spherical, right? Spherical in shape. So it is a concave mirror. So if we observe, if we extend these points, it seems like a circle, right? So in this circle, the midpoint we are calling it as, it is a center of sphere of which mirror is a part. So it is a sphere, center of sphere. So spherical mirror. So in that, this mirror is a part. Look here, this is a sphere. In the sphere, this is a part of that sphere. Mirror is a part of the sphere. I think it's clear now. So one is, if we consider a center point of the mirror, we are calling it as a pole. And this mirror, if you consider it as a sphere, whole sphere, in that whole sphere, if we consider a midpoint, we are calling it a center of curvature. Okay, then what do you mean by radius of curvature? Radius of curvature, in that what we call it as radius. So radius means the distance between the center and to the circumference of circle, right? For example, if I consider a circle, this is center. From this center we are calling it as, this is a radius. The same definition here we are giving, that is the distance between center of curvature and pole of the mirror. So here this is the pole, that is circumference, if we consider like that. Okay, this is the center of curvature. The distance between this we are calling it as a radius of curvature. Either it is a concave mirror, either it is a convex mirror. I think clear. Pole, center of curvature, radius of curvature. Next part is principal axis. So principal axis, now I am going to take, so now if I consider a mirror like this, so what is the center part we call it as? So here if I consider a mirror, so this center part we can call it as a pole, right? So here if I take it as a circles, so circle like that, so this middle point we are calling it as center of curvature. The distance between these two, means center of curvature and pole, we are calling it as radius of curvature. Yes, right. Now principal axis means a straight line passing through the center of curvature and a pole. If I consider the straight line like this, which is passing through the center of curvature and pole of the mirror, that line we are calling it as principal axis. Axis means, as you know, that x-axis and y-axis, that means it is a line, right? That's what we are giving. It's a straight line passing through center of curvature and the pole. Okay. Next, if we come to the next part, that is principal focus. This is very important, principal focus. So now what we call it as principal focus means, so as you all know, we are talking about a mirror. So if I consider a mirror and I'm taking a mirror and the ray, which is, now let us say that a light is falling on this mirror. As you all know, the property of mirror, it reflects back, right? Mirror means it reflects back. So all what happens, the light reflects back and all light will fall, they combine, they converge at one point, they meet at one point. Okay, understand clearly. So when light falls on the mirror, it may be concave mirror or it may be convex mirror. So what is the main property of mirror? It reflects back, it reflects the light rays. So all these light rays, they meet at one point. So that point we are calling it as principal focus. That means that point will falls on the principal axis. Look here, it falls on the principal axis only. Okay, that's what the definition. In concave mirror, rays of light parallel to the principal axis after reflecting meet at point on the principal axis called principal focus. I think it's clear. So when a light, understand carefully, in concave mirror, rays of light parallel to principal axis. So this is the principal axis now. Here for this parallel lines they are falling. So after falling on the mirror, it will reflects back and therefore they meet at one point, all the rays. So they meet at this principal axis only. So it is that point we are calling it as principal focus. Okay. Next it is focal length. Focal length. So focal length is the distance between pole and the principal focus. Remember, there is a difference between radius of curvature and focal length. Okay, don't confuse here. Here you have difference between radius of curvature and focal length. Radius of curvature means the distance between, if I consider the mirror and center of curvature, the distance between center of curvature and the pole, we are calling it as radius of curvature. But in principle, the light rays, here the light rays are they are meeting at one point. This we call it as principal focus. So from that to the pole of the mirror, we are calling it as focal length. So radius of curvature is different, focal length is different. Radius of curvature means the distance between center of curvature and pole. But here this focal length means it is a distance between pole and the principal focus. Okay, it's clear. But if you come to the relationship between those two, means radius of curvature and the pole of the mirror, it is like this: r is equal to 2f, r is equal to 2f, or f is equal to r by 2. So if we take 2 times of focal length, it will be equal to radius. Or if we take, if we take half of radius of curvature, you will get focal length. I think it's clear. So focal length, principal axis and principal focus. Here you can see the both. If I consider this one, that is, which is this concave mirror, concave mirror. So this is center of curvature, and this is pole of the mirror, the midpoint of the mirror, we are calling it as pole of the mirror. The distance between center of curvature and pole of the mirror, we call it as radius of curvature. Okay, now if the parallel lines, if it falls on the mirror, they all reflect back and they all meet at one point. This we call it as principal focus. Now the distance between these two, distance between principal focus and this is, we call it as focal length. Now you can observe, this is radius of curvature, this is focal length. Yes, right, twice. If you take twice of focal length, you will get the radius of curvature. Okay, this is in concave mirror. This is about convex mirror. And remember, here you can observe, this is a concave mirror and here light rays are converging at one point, right? They are meeting at point. So concave mirror, we call it as converging mirror. Remember, again I'm repeating, concave mirror is converging mirror. Means the light are converging, they are meeting at one point. But if we come to the convex mirror, what happens here? If the light fall on this mirror, what happens? They diverge, they do not meet at one point. But what we will do, imaginarily we take lines, means they meet at one point. ಇಲ್ಲಿ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ, ಅಲ್ಲೇನಾಗ್ತಿತ್ತು, ಲೈಟ್ ಮಿರರ್ ಮೇಲೆ ಬಿದ್ದರೆ ಅದೆಲ್ಲ ಸೇರಿ ಒಂದು ಪಾಯಿಂಟಲ್ಲಿ ಮೀಟ್ ಆಗ್ತಿತ್ತು. ಆದರೆ ಕಾನ್ವೆಕ್ಸ್ ಮಿರರಲ್ಲಿ ಆ ಥರ ಆಗಲ್ಲ, ಸ್ಪ್ಲಿಟ್ ಆಗಿಬಿಡುತ್ತೆ, ಡೈವರ್ಜ್ ಆಗುತ್ತೆ. ಆದರೆ ನಾವೇ ಇಮ್ಯಾಜಿನರಿಯಾಗಿ ಇಂಥ ಕಡೆ ಇಲ್ಲಿ ಬರಬಹುದು ಅಂತ ನಾವು ಇಮ್ಯಾಜಿನ್ ಮಾಡ್ಕೋತೀವಿ. ಅಲ್ಲಿ ಬಂದಿರಲ್ಲ, ಇಮೇಜ್ ಫಾಲ್ ಆಗಿರಲ್ಲ. ಸೊ ನಾವೇನು ಮಾಡ್ತೀವಿ, ಇಮ್ಯಾಜಿನ್ ಮಾಡ್ಕೋತೀವಿ. ಸೊ ಅದಕ್ಕೆ ನಾವು ಇಲ್ಲಿ ಡಾಟೆಡ್ ಲೈನ್ಸಲ್ಲಿ ತೋರಿಸಿದ್ದೀವಿ. ಸೊ ದಿಸ್ ವಿ ಕಾಲ್ ಇಟ್ ಅಸ್, ಅದಕ್ಕೆ ಇದನ್ನು ನಾವು ಡೈವರ್ಜಿಂಗ್ ಮಿರರ್ ಅಂತ ಕರಿತೀವಿ, ಡೈವರ್ಜಿಂಗ್ ಮಿರರ್. ಸೊ ಬಟ್ ಇನ್ ಕಾನ್ಕೇವ್ ಮಿರರ್ ಇಸ್ converging mirror, convex mirror is diverging mirror. I think it's clear now. Okay, so let's move on to the next concept, uses of spherical mirror. So now finally ಈಗ ನಾನು uses ಬಂದೆ. ಇದಾದ್ಮೇಲೆ actually as soon as that parts ಎಲ್ಲ ಹೇಳಾದ್ಮೇಲೆ we have to discuss about ray diagrams, but I kept separate video for ray diagrams. After that part, that means after completion of the parts of or pole like focal length like this, I used to explain the ray diagrams, but to clear, so understand, to make you to understand better, so I did separate video for ray diagrams. Now let's move on to the uses of spherical mirrors. This is the last concept in the mirror and we have some formulas also we'll discuss. So concept, afterwards we'll go for formula. So if you come particular to the concave mirror, where we use this concave mirror, the first one is torch. Concave mirror are used in torch, or you can call it as searchlight. Searchlight, there is a difference between torch and searchlight. You can observe in these two figures. Searchlight means it will be the whole huge distance, it falls on the huge distance. And headlights of vehicle, you can observe the headlights of vehicle also. So the first use is concave mirror are used in torch, searchlight, headlights of the vehicles. Then it is used in shaving mirrors to see the larger image of the face. So it is used in shaving mirrors. and they are used by dentist. You can observe the dentist see the larger image of the teeth. So they used by dentist, and it is used in solar furnace. Solar furnace. So if you consider solar furnace, it is a huge, it will take a large amount of heat from the sun. Okay, solar furnace. These are the 4 important uses of concave mirror. They may ask for 1 mark. Write any 2 uses of concave mirror. So you can write it there. It is used in torch, searchlight, headlight of vehicles. It is used in shaving mirror. It is used by dentists to see the larger image of teeth, and it is used in solar furnace. These are the uses of concave mirror. Next one is use of convex mirror. Here you can observe only the one main use, and here they asked in give reason part also. This question is very important. So here it is used in concave mirror, used in rear view mirrors in vehicles. Why rear view means you can call it as side mirrors. So you can observe the side mirrors of vehicles, right? So convex mirror is used in rear view mirrors in vehicles. Why it is used in rear view? What is the main? Means convex mirror get erect and diminished image of the object. They also have a wider field of view than plane mirrors. Here you can observe, right? So in whole, the small mirror will capture the whole thing, which is your backside, right? Yes, you can observe, you can think once. So the whole small mirror will capture the whole like a this tractor, or you can take lorry or a bus or something. The whole road is covered by this small mirror, right? So that's why we are calling it as a diverging mirror. Diverging means it will take a wide range. ತುಂಬಾ ಡೈವರ್ಜ್ ಮಾಡಿ ಪೂರ್ತಿ ಅಲ್ಲಿರೋದಷ್ಟು ಮಾಡುತ್ತೆ. ಆದರೆ ಕಾನ್ಕೇವ್ ಮಿರರ್ ಆ ಥರ ಅಲ್ಲ. ಅದು ಯಾವುದು ಸ್ಮಾಲ್ ಪಾರ್ಟ್, ಇಟ್ ವಿಲ್ ಟೇಕ್ ಅ ಸ್ಮಾಲರ್ ಪಾರ್ಟ್. ಸೊ ಇಟ್ ವಿಲ್ ಕನ್ವರ್ಜ್ ಅಟ್ ಒನ್ ಪಾಯಿಂಟ್, ಬಟ್ ಇಟ್ ವಿಲ್ ನಾಟ್ ಕನ್ವರ್ಜ್, ಇಟ್ ವಿಲ್ ಡೈವರ್ಟ್. ಸೊ ಆಸ್ ಇಟ್ ಈಸ್ ಅ ಡೈವರ್ಟಿಂಗ್ ಮಿರರ್ ಫ್ರಮ್ ದಿಸ್ small mirror, you can observe the wide range. Okay, this is what the main reason why the convex mirrors are used in rear view, or you can call it as side mirrors in the vehicles. Okay, so next, if you go for next one, properties of images, the main thing. ಹಾಗಾದರೆ ನಮ್ಮ ಇಮೇಜಸ್ ಯಾವ್ಯಾವ ಥರ ಇರುತ್ತೆ. ನಂಬರ್ 1 ಬಂದರೆ ರಿಯಲ್ ಆ್ಯಂಡ್ ವರ್ಚುವಲ್. ಇದ್ರ ಬಗ್ಗೆ ತುಂಬ ಕ್ಲಿಯರಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು, ಬಿಕಾಸ್ ದಿಸ್ ಇಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ವೆನ್ ಯು ಆರ್ talking about the ray diagrams. Okay, first one is we have real and virtual. So if you observe this case, so niಮಗೆ ಗೊತ್ತಿದೆ how many types of mirrors are there. One is concave mirror, convex mirror. Concave mirror is converging mirror. That means they will all meet at one point. But in convex mirror, they will not meet at one point. Okay, they will not at all meet at one point. So here you are seeing the object, but it is not forming the object. Imaginary, as I told you, only the rays we can imagine, the image will fall on this place. So this is real image, virtual image, we can say it as. That means in concave mirror, the images are real. In convex mirror, the images are virtual. Virtual means it is just an imaginary. Clear? Next, if we come to the images, one will be invert, another will be erect. So sorry, this is not diminished, this is erect. We can write it as erect, change it as erect. So one will be invert and another will be erect. What do you mean by invert and erect? What do you mean by invert and erect? You can see the object. So here the image is like reverse. So it is like a invert, right? Ulta ide nimma image ulta. So this, if it is image is like this, we are calling it as invert image. If image how it is presenting like that only, it is viewing like that only, we are calling it as erect. Artha ಮಾಡ್ಕೊಳ್ಳಿ, image itra idre ulta idre, it is called as invert image. Invert ನೀವು ಹೇಗಿದೆ ಹಂಗೆ ಸ್ಟ್ರೈಟ್ ಆಗಿ ಬಂದ್ರೆ it is erect image. I think it's clear. Then in the last part, we are calling it as same size and enlarged and diminished. Same size means how the size of image will be same. ಎಷ್ಟಿದೆಯೋ ಅಷ್ಟೇ ಇರೋ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, if it is like for example, usually 4 meters, if an image is 4 meter, or if an object, if you consider object and image are the same size, so same size. Enlarge means object ಇಷ್ಟಿದ್ರೆ image ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಇರೋದು. If it is more, so we are calling it as enlarge. Diminished means it is reverse. That means object ಇಷ್ಟಿದ್ರೆ image ಇಷ್ಟು ಬರೋದು. ನೋಡಿರ್ಬೋದು ಇದನ್ನೆಲ್ಲ, you can observe you making an enlarge, ದಪ್ಪ ಕಾಣಿಸೋದು ಅಥವಾ ಉದ್ದ ಕಾಣಿಸೋದು, like this. Yes, right? So this is about the images. So images will be real and virtual. So real means they converge ಆಗಿ ಒಂದು ಪಾಯಿಂಟಲ್ಲಿ ಮೀಟ್ ಆಗಿ ಬರೋವಂಥದ್ದು real image. ಡೈವರ್ಜ್ ಆಗಿ ನಾವೇ ಇಂಥ ಕಡೆ ಮೀಟ್ ಆಗಬಹುದು ಅನ್ನೋದನ್ನು ತಗೊಳ್ಳೋದು, ಇಟ್ ಇಸ್ ವರ್ಚುವಲ್ ಇಮೇಜ್. ಓಕೆ, ಆ್ಯಂಡ್ ಇಮೇಜಸ್ ವಿಲ್ ಬಿ ಇನ್ವರ್ಟ್ ಆ್ಯಂಡ್ ಎರೆಕ್ಟ್. ಇನ್ವರ್ಟ್ ಮೀನ್ಸ್ ರಿವರ್ಸ್, ಉಲ್ಟಾ. ಎರೆಕ್ಟ್ ಮೀನ್ಸ್ ಸೀದಾ ಹಾಗೆ ಇರೋದು ಅಂತ. ಸೊ ಆಮೇಲೆ ಇಮೇಜಸಲ್ಲಿ ಸೇಮ್ ಸೈಜ್ ಇರ್ಬೋದು, ಆಬ್ಜೆಕ್ಟ್ ಟು ಇಮೇಜ್ ಎರಡು ಒಂದೇ ಸೈಜ್ ಇರ್ಬೋದು, ಆರ್ ಆಬ್ಜೆಕ್ಟ್ಗಿಂತ ಇಮೇಜೇ ಜಾಸ್ತಿ ದೊಡ್ಡದಿರ್ಬೋದು, ಸೊ ದಟ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಎನ್ಲಾರ್ಜ್, ಅಥವಾ ಆಬ್ಜೆಕ್ಟ್ಗಿಂತ ಇಮೇಜ್ ಚಿಕ್ಕದಾಗಿರ್ಬೋದು, ಸೊ ದಟ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಡಿಮಿನಿಷ್ಡ್. ಸೊ ದಿಸ್ ಇಸ್ ಅಬೌಟ್ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ಇಮೇಜಸ್. Finally, if you come to the mirror, you have two formulas that you have to remember. One is mirror formula, another one is magnification. Mirror formula ಅಂತಂದ್ರೆ ನಿಮಗಿಲ್ಲಿ UVF ಬರುತ್ತೆ. ಓಕೆ, ನಾವು ಮಿರರ್ ಬಗ್ಗೆ ಡೀಟೇಲಾಗಿ ತಿಳ್ಕೊಂಡ್ರೆ ನೋಡಿ, ಇಲ್ಲಿ ಇದು ಮಿರರ್ ನೋಡ್ಕೊಳ್ಳಿ, ಮಿರರ್ ಬಗ್ಗೆ ಇದು. ನೆಕ್ಸ್ಟ್ ಬಂದರೆ ಇದು ಪ್ರಿನ್ಸಿಪಾಲ್ ಆಕ್ಸಿಸ್. ಓಕೆ, ಈಗ ನೀವು ಇಲ್ಲೊಂದು ಆಬ್ಜೆಕ್ಟ್ ಇಟ್ಟಿದ್ದೀರಾ, ಸೊ ನಿಮ್ಮ ಇಮೇಜು ಇಲ್ಲೆಲ್ಲೋ ಕನ್ವರ್ಜ್ ಆಗಿ ಇನ್ನೊಂದು ಇಮೇಜ್ ಬಂದಿದೆ ಅಂತ ಅಂದ್ಕೊಳ್ಳೋಣ. ಸೊ ಈ ಆಬ್ಜೆಕ್ಟಿಂದ ಮಿರರ್ಗಿರೋ ಅಂಥ ಡಿಸ್ಟೆನ್ಸ್ನ ಯು ಅಂತ ಕರಿತೀವಿ. ಓಕೆ, ಸೊ ನಿಮ್ಮ ಇಮೇಜು ಇನ್ನೆಲ್ಲೋ ಚಿಕ್ಕದಾಗಿ ರಿಫ್ಲೆಕ್ಟ್ ಆಗಿ ಇಲ್ಲಿ ಬಂದಿದೆ ಅಂತ ಅಂದ್ಕೊಳ್ಳೋಣ. ಸೊ ಇಲ್ಲಿ ಇಮೇಜಿಂದ ಪೋಲ್ಗೆ ಇರೋಂಥ ಅಥವಾ ಮಿರರ್ಗೆ ಇರೋಂಥ ಡಿಸ್ಟೆನ್ಸ್ನ ವಿ ಅಂತ ಕರಿತೀವಿ. ಆಮೇಲೆ ಫೋಕಲ್ ಲೆಂತ್ ಅಂದರೆ ಗೊತ್ತಿದೆ ನಿಮಗೆ, ಎಲ್ಲ ಎಫ್ ಅಂದರೆ ಫೋಕಲ್ ಲೆಂತ್ ಇಲ್ಲಿ. ಸೊ ಎಲ್ಲ ಕನ್ವರ್ಜ್ ಆಗಿ ಒಂದು ಕಡೆ ಮೀಟ್ ಆಗಿ ಅಲ್ಲಿಂದ, ಸೊ ದ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ಪ್ರಿನ್ಸಿಪಾಲ್ ಫೋಕಸ್ ಆ್ಯಂಡ್ ದ ಮಿರರ್, ಸೊ ಅಲ್ಲಿ ನಾವೇನು ಕರಿತೀವಿ ಎಫ್ ಅಂತೀವಿ. ಸೊ ಆ ಮೂರಕ್ಕೂ ಇರೋ ರಿಲೇಷನ್ನ ಒಂದು ಫಾರ್ಮುಲಾ ಮಾಡಿದ್ದಾರೆ, 1/v + 1/u = 1/f. ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ mirror formula. What is a mirror formula? They may ask for 1 mark also. Write the mirror formula. 1/v plus v andre image distance. Look here, v it is image distance. U it is object distance. F it is focal length. Okay, F it is focal length. Now if we go for next, magnification andre agle heladvalla. So as I told, the smaller one seems like a bigger one, or bigger one will seems like a smaller one. Eshtu magnify aitu, jaasti aita kadme aita. So that for that we have one formula, two formulas related to their height or related to their distance. Eradu formula ide. This is one formula, that is you can consider their height of image by height of object, or you can consider distance also. V means image distance, u means object distance. If we take negative sign, -v/u. These are the two formulas, ಒಂದೇ ಅಲ್ಲ, ಬೇರೆ ಫಾರ್ಮುಲಾ ಇದು. ಸೊ ಒಂದು ಮ್ಯಾಗ್ನಿಫಿಕೇಶನ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋಕ್ಕೆ you can consider height of image by height of object, and the one is you can consider distance, means image distance by object distance. You have to consider negative sign, m is equal to -v/u. Okay, this is all about reflection of light. So let's move on to the next concept, that is refraction of light. So what is this refraction of light? When light travels from one transparent medium into the another, it gets bent. This bending of light is called refraction of light. Gottide alla nimge? Hinge nodi, observe ಮಾಡಿ. A pencil is dropped into glass of water. Here the pencil is bent into glass of water. So how it seems like it is bending, right? ಒಂಥರ ಇಲ್ಲಿ ಕಟ್ಟಾದಂಗೆ ಅನಿಸ್ತಿದೆಲ್ಲ. ಸೊ ಇಟ್ ಇಸ್ ನಾಟ್, ಬಟ್ ಹಂಗಾಗಿಲ್ಲ, ಬಟ್ ನಿಮ್ಗೆ ನೋಡೋಕೆ ಆ ಥರ ಅನ್ನಿಸ್ತಿದೆ. ಸೊ ದಿಸ್ ವಿ ಆರ್ ಕಾಲಿಂಗ್ ಇಟ್ ಆಸ್ refraction of light. Why it is? ಯಾಕೆ ಅಂತಂದರೆ, here what is happening, the light is traveling from one medium to another medium, that is from air. ಗ್ಲಾಸಿಂದ ಆಚೆಗೆ ಯಾವ ಮೀಡಿಯಮ್ ಇದೆ? ಏರ್ ಮೀಡಿಯಮ್ ಇದೆ. ಬಟ್ ಇನ್ಸೈಡ್ ಇಟ್ ಇಸ್ ಟ್ರಾವೆಲಿಂಗ್ ಟು ದ ವಾಟರ್ ಮೀಡಿಯಮ್, ರೈಟ್? When light travels from one medium to another medium, the light bends. So that bending of light we are calling it as refraction of light. Okay, so this is air medium, this is water medium. So the ray which strikes that incident ray ಅಂತ ಕರಿತೀವಿ, ಬೆಂಡ್ ಆಗೋದು, ಅಲ್ಲಿ ರಿಫ್ಲೆಕ್ಟ್ ಆಗ್ತಿತ್ತು. But here it is refracting, so it is called as refracted ray. And the between them we are calling it as same as normal line, and also same as angle of incidence. But here instead of angle of reflection, we are calling it as angle of refraction. I think it's clear. When a light travels from one medium to another medium, the light bent. So this bending of light we are calling it as refraction of light. Clear? Next one is, here you can observe clearly ಯಾವ ಥರ ಬೆಂಡ್ ಆಗುತ್ತೆ, ಹೇಗೆ ಬೆಂಡ್ ಆಗುತ್ತೆ ಅಂತಂದರೆ, here we have two types of medium. One is rarer medium and the one is denser medium, or in other words we can say that lighter medium ಅಂದರೆ air is lighter medium, ಹೌದಾ? ಸೊ air is lighter but water is heavier. Okay, air is lighter, glass is heavier. ಅರ್ಥ ಆಗ್ತಿದೆ ಅಂತ ಅನ್ಕೋತೀನಿ. ಆ ಜಾಗದಲ್ಲಿ ವಿ ಆರ್ ಕಾಲಿಂಗ್ ಇಟ್ ಆಸ್ ರೇರರ್ ಮೀಡಿಯಮ್ ಆ್ಯಂಡ್ ಡೆನ್ಸರ್ ಮೀಡಿಯಮ್ ಅಂತ ಹೇಳ್ತಿದ್ದೀವಿ ಅಷ್ಟೇ. ಸೊ ವಾಟ್ ಈಸ್ ಅಂದರೆ ಏನಾಗುತ್ತೆ, ವೆನ್ ಇಟ್ ಟ್ರಾವೆಲ್ಸ್ ಫ್ರಮ್ ಸಮ್ ಟೈಮ್ಸ್ ಈಗ ಲೈಟು ಏರಿಂದ ವಾಟರ್ ಮೂವ್ ಆಗುತ್ತೆ, ಅಥವಾ ವಾಟರಿಂದ ಏರ್ಗೆ ಹೋಗುತ್ತೆ, ಅಥವಾ ಏರಿಂದ ಗ್ಲಾಸಿಗೆ ಬರುತ್ತೆ, ಅಥವಾ ಗ್ಲಾಸಿಂದ ವಾಟರ್ಗೆ ಹೋಗುತ್ತೆ. ಈ ಥರ ಬೇರೆ ಬೇರೆ ನಾವು ಮೀಡಿಯಮ್ ತೊಗೊಂಡ್ರೆ ಒನ್ ವಿಲ್ ಬಿ ರೇರರ್ ಮೀಡಿಯಮ್, ಅನದರ್ ವಿಲ್ ಬಿ ಡೆನ್ಸರ್ ಮೀಡಿಯಮ್. ಓಕೆ, ಸೊ ಈಗ ಅಬ್ಸರ್ವ್ ಮಾಡೋಣ, ರೇರರ್ ಮೀಡಿಯಮ್ ಇಂದ ಡೆನ್ಸರ್ ಅಂದರೆ ಓವರ್ ಆಲ್ ಇಟ್ ಇಸ್ ಡಿವೈಡೆಡ್ ಇಂಟು ಟು ಮೀಡಿಯಮ್. ಹಿಯರ್ ಪರ್ಟಿಕ್ಯುಲರ್ ವಿ ಆರ್ ನಾಟ್ ಸೇಯಿಂಗ್ ಅಬೌಟ್ ವಾಟರ್ ಆರ್ ಏರ್, ವಾಟರ್ ಆರ್ ಗ್ಲಾಸ್ ಲೈಕ್ ದಿಸ್. ಸೊ ಫಸ್ಟ್ ವೆನ್ ಲೈಟ್ ಟ್ರಾವೆಲ್ಸ್ ಫ್ರಮ್ ರೇರರ್ ಮೀಡಿಯಮ್ ಟು ಡೆನ್ಸರ್ ಮೀಡಿಯಮ್, ಅಂದರೆ ಏರಿಂದ ವಾಟರ್ಗೆ ಹೋಗ್ತಿದೆ ಅಂದ್ಕೊಳ್ಳೋಣ, ಏರಿಂದ ವಾಟರ್ಗೆ, ಇಟ್ ಬೆಂಡ್ಸ್ ಟುವರ್ಡ್ಸ್ ನಾರ್ಮಲ್. ಅಂದರೆ ಲೈಟ್ ರೇ ಬೆಂಡ್ ಆಗೋದು ನಾರ್ಮಲ್, ಇದನ್ನು ನಾವು ನಾರ್ಮಲ್ ಲೈನ್ ಅಂತ ತಗೋತೀವಲ್ಲ ಅದ್ರ ಕಡೆ ಬೆಂಡ್ ಆಗುತ್ತೆ, ಅಂದರೆ ಆ್ಯಂಗಲ್ ಆಫ್ ರಿಫ್ರಾಕ್ಷನ್ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಸೊ ನಾವು ಇದನ್ನು ಆ್ಯಂಗಲ್ ಆಫ್ ರಿಫ್ರಾಕ್ಷನ್ ಅಂದರೆ ಕಡಿಮೆ ಆಗುತ್ತಾ ಹೋಗುತ್ತೆ. ಅದೇ ಲೈಟು ವೆನ್ ಲೈಟ್ ಟ್ರಾವೆಲ್ಸ್ ಫ್ರಮ್ ಡೆನ್ಸರ್ ಟು ಮೀಡಿಯಮ್, ಅಂದರೆ ವಾಟರಿಂದ ಏರ್ಗೆ ಬರ್ತಿದೆ ಅಂತ ಅಂದ್ಕೊಳ್ಳೋಣ. ಇಲ್ಲಿ ವಾಟ್ ವಿ ಕ್ಯಾನ್ ಕನ್ಸಿಡರ್ ಏರ್ ಟು ವಾಟರ್, ಬಟ್ ಹಿಯರ್ ವಾಟರ್ ಟು ಏರ್ ಅಂತ ತೊಗೊಂಡ್ರೆ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಹಿಯರ್ ದ ಲೈಟ್ ಬೆಂಡ್ಸ್ ಅವೇ ಫ್ರಮ್ ದ ನಾರ್ಮಲ್, ನಾರ್ಮಲಿಂದ ದೂರ ಹೋಗುತ್ತೆ. ಅವಾಗ ಆ್ಯಂಗಲ್ ಆಫ್ ರಿಫ್ರಾಕ್ಷನ್ ಏನಾಗುತ್ತೆ, ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಐ ಥಿಂಕ್ ಇಟ್ಸ್ ಕ್ಲಿಯರ್ ನಾವು. ಸೊ ಹಿಯರ್ ವೆನ್ ಲೈಟ್ ಟ್ರಾವೆಲ್ಸ್ ಅಂದರೆ ಬೆಂಡಿಂಗಲ್ಲೂ ಯಾವ್ಯಾವ ಥರ ಬೆಂಡ್ ಆಗುತ್ತೆ ಅಂತ ಅಷ್ಟೇ. ಓಕೆ, ಸೊ ವೆನ್ ಲೈಟ್ ಟ್ರಾವೆಲ್ಸ್ ಫ್ರಮ್ ರೇರರ್ ಮೀಡಿಯಮ್ ಟು ಡೆನ್ಸರ್ ಮೀಡಿಯಮ್ ಇಟ್ ಬೆಂಡ್ಸ್ ಟುವರ್ಡ್ಸ್ ದ ನಾರ್ಮಲ್. ವೆನ್ ಲೈಟ್ ಟ್ರಾವೆಲ್ಸ್ ಫ್ರಮ್ ಡೆನ್ಸರ್ ಮೀಡಿಯಮ್ ಟು ರೇರರ್ ಮೀಡಿಯಮ್ ಇಟ್ ಬೆಂಡ್ಸ್ ಅವೇ ಫ್ರಮ್ ದ ನಾರ್ಮಲ್. I think remember these two. Next one, here also we have two laws of refraction, and this is very 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 important. You can mark it down, very important. So here also the first law is, it is similar to the reflection. What is that law? The incident ray, refracted ray, normal line all lies on the same plane. Here you can write it as incident ray, refracted ray, normal line all lies on the same line. ಅಲ್ಲಿ ಏನು ಹೇಳ್ತಿದ್ವಿ, ಇನ್ಸಿಡೆಂಟ್ ರೇ, ರಿಫ್ಲೆಕ್ಟೆಡ್ ರೇ, ನಾರ್ಮಲ್ ಅಂತಿದ್ವಿ. ದಿಸ್ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ರಿಫ್ಲೆಕ್ಟೆಡ್ ಚೇಂಜಸ್ ಇಟ್ ಆಸ್ ರಿಫ್ರಾಕ್ಟೆಡ್ ಅಷ್ಟೇ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಬಂದರೆ ಯು ಹ್ಯಾವ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಆಸ್ ವೆಲ್ ಆಸ್ ಫಾರ್ಮುಲಾ. ಈ ಫಾರ್ಮುಲಾನೇ ನೀವು ನೆನ್ಪಿಟ್ಕೊಂಡ್ರೆ ಸಾಕು ಸೆಕೆಂಡ್ ಲಾಗೆ. ಓಕೆ, ಸೊ ದ ರೇಷಿಯೋ ಆಫ್ ಸೈನ್ ಆಫ್ ಆಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್ ಟು ದ ಸೈನ್ ಆಫ್ ಆಂಗಲ್ ಆಫ್ ರಿಫ್ರಾಕ್ಷನ್ ಇಸ್ ಕಾನ್ಸ್ಟ್ಯಾಂಟ್. ಓಕೆ, ಫಾರ್ ಲೈಟ್ ಆಫ್ ಗಿವನ್ ಕಲರ್ ಆರ್ ಫಾರ್ ಅ ಗಿವನ್ ಪೇರ್ ಆಫ್ ಮೀಡಿಯಾ. ಅದನ್ನು ನಾವು ಸ್ನೆಲ್ಸ್ ಲಾ ಅಂತ ಕೂಡ ಕರಿತೀವಿ. ಈ ಲಾನ್ ಏನಂತ ಕರಿತೀವಿ, ಸ್ನೆಲ್ಸ್ ಲಾ ಅಂತ ಕೂಡ ಕರಿತೀವಿ, ಸ್ನೆಲ್ಸ್ ಲಾ. ಓಕೆ, ಸೊ ಆರ್ ಯು ಕ್ಯಾನ್ ಸೈನ್ ಐ ಬೈ ಸೈನ್ ಆರ್. ಈ ಸೈನ್ ಕಾಸ್ ಇದೆಲ್ಲ ನಾವು ವಿಲ್ ಟಾಕ್ ಇಟ್ ಅಬೌಟ್ ಟ್ರಿಗ್ನೋಮೆಟ್ರಿ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀವಿ. ಜಸ್ಟ್ ಯು ರಿಮೆಂಬರ್ ದಿಸ್ ಲಾ, ಸೈನ್ ಐ ಬೈ ಸೈನ್ ಆರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಕಾನ್ಸ್ಟಂಟ್. Sin I by sin R is equal to constant. So these are the two laws of refraction. First law na same as usual, but second law na sin I by sin R is equal to constant anta bareyri. Next hodre ಅದೇ ರಿಫ್ರಾಕ್ಷನ್ ಗ್ಲಾಸ್ ಪ್ರಿಸಮ್ಗೆ ಹೋದ್ರೆ ಏನಾಗುತ್ತೆ, ಇಷ್ಟೊತ್ತು ನಾವೇನಂತ ಹೇಳಿದ್ವಿ, ವೆನ್ ಲೈಟ್ ಟ್ರಾವೆಲ್ಸ್ ಫ್ರಮ್ ಏರ್ ಟು ವಾಟರ್. ಬಟ್ ನಾವು ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ವೆನ್ ಇಟ್ ಟ್ರಾವೆಲ್ಸ್ ಥ್ರೂ ಗ್ಲಾಸ್ ಸ್ಲ್ಯಾಬ್. ಹಿಯರ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್, ಇಲ್ಲಿ ನೋಡ್ಕೊಂಡು ಬನ್ನಿ. ಈಗ ಏನಾಗ್ತಿದೆ, ಫಸ್ಟು ಗ್ಲಾಸ್ ರೇ ಇಟ್ ಇಸ್ ಕಮಿಂಗ್ ಫ್ರಮ್ ಏರ್ ಟು ಗ್ಲಾಸ್. ಏರ್ ಈಸ್ ರೇರರ್ ಮೀಡಿಯಮ್, ಗ್ಲಾಸ್ is denser medium. Yes, right? If it is moving from, what happens? Rarer to denser, yes, it is bending towards normal. Okay, then what is happening? Now this line is acting as an incident ray. Now refracted ray only it is. Now what is happening now? It is traveling from glass to air. That means denser medium to rarer medium. It bends away from the normal. Nodkobodu, first it will falls, then it bends towards normal. Yakandre rarer to denser. Next denser to rarer, so it is away. So here this is very important, and this is very important figure also. Idin kuda kelidare 2 marks ge, write the knee diagram of refraction of light through glass slab anta. So practice this. So here this is incident ray, angle of incidence, normal line. Again this is an angle of reflection. This is a refracted ray. Again it is falling on the normal. Okay, then final agi aache baruttalla, idanna navu enanta kartivi, refracted anta helala. That we are calling it as emergent ray. Angle of emergence anta kartivi. Finally it will come from denser to rarer, right? So it is moving. This is, we are calling it as emergent ray. This we are calling it as angle of emergence. Angle of emergence. Okay, so angle of incidence, angle of refraction, refracted ray, emergent ray. Okay, this is about the refraction through glass slab. Onsari nodkolli, ಏರಿಂದ ಗ್ಲಾಸಿಗೆ ಬಂತು, ಆಮೇಲೆ ಗ್ಲಾಸಿಂದ ಏರಿಗೆ ಬಂತು. ರೇರರ್ ಟು ಡೆನ್ಸರ್, ಡೆನ್ಸರ್ ಟು ರೇರರ್. ಕ್ಲಿಯರ್? ನೆಕ್ಸ್ಟ್ ಈಸ್ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್. ಅಂದರೆ ಈಗ ತಾನೇ ನಾವು ಸೆಕೆಂಡ್ ಲಾ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. ಸೆಕೆಂಡ್ ಲಾ ಅಂತಂದರೆ ಏನು ಹೇಳಿದ್ವಿ ನಾವು, ಸೈನ್ ಐ ಬೈ ಸೈನ್ ಆರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಕಾನ್ಸ್ಟೆಂಟ್, ರೈಟ್? Sin R by sin R is equal to constant. That constant we are calling it as refractive index. We call it as refractive. That the refractive index of a medium is the ratio of speed of light in air or vacuum to the speed of light in medium. So ಇಲ್ಲಿ C ಅಂದರೆ speed of light in air. So that is constant ನಿಮಗೆ ಗೊತ್ತಿದೆ 3 into 10 to the power of 8. So this we are calling it as speed of light. Speed of light in air or vacuum. ಈ v ಅನ್ನೋದನ್ನ ಏನಂತ ಕರಿತೀವಿ, ಸ್ಪೀಡ್ ಆಫ್ ಲೈಟ್ ಇನ್ ಮೀಡಿಯಂ. ಯಾವ ಮೀಡಿಯಂ ಬೇಕಾದರೂ ಆಗಿರ್ಬೋದು. So glass medium, water medium, anything else, but C is fixed here. C is fixed here. So n is called as refractive index or index of refraction. So what we can write it as n is equal to C by V. So definition ಕೇಳಿ, formula ಕೇಳಿ, ಏನು ಬರೀರಿ, n is equal to C by V. Okay, C is speed of light in air or vacuum. V is speed of light in medium. Clear? So next ಬರೋಣ. ಈಗ ನೋಡ್ಕೊಂಡು ಬನ್ನಿ, ಇಲ್ಲಿ ನಿಮ್ಗೆ ಒಂದಷ್ಟು ಟೇಬಲ್ ಇದೆ. ಸೊ ದಿಸ್ ಟೇಬಲ್ ಇಟ್ ಈಸ್ ಇನ್ ಯೋರ್ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಆಲ್ಸೋ. ದಿಸ್ ಆರ್ ಆಲ್ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಆಫ್ ಈಚ್ ಮೆಟೀರಿಯಲ್. ದಿಸ್ ಇಸ್ ದ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಆಫ್ ಈಚ್ ಮೆಟೀರಿಯಲ್. ಈ ಟೇಬಲ್ನ ಡೋಂಟ್ ಬಹೈಡ್ ದಿಸ್ ಟೇಬಲ್, ಯು ನೋ ನೀಡ್ ಟು ಬಹೈಡ್ ದಿಸ್ ಟೇಬಲ್. ಓನ್ಲಿ ಥಿಂಗ್ ಇಸ್ ದೇ ವಿಲ್ ಆಸ್ಕ್ ಒನ್ ಡೆಫಿನೇಷನ್. The refractive index of diamond is 2.42. What do you mean by this statement? For this, what you can write is the ratio of, so what you can write, the ratio, n is equal to, we wrote n is equal to C by V, right? C is speed of light in vacuum. So this is speed of light in medium. Which medium we are taking? Diamond now. So what you can write? Definition. What do you mean by that statement? Means the refractive index, or you can consider the ratio of speed of light in vacuum to the ratio of speed of light in diamond is equal to 2.42. Again I am repeating. So or either ones, we can take other one like glass, crown glass. The refractive index of crown glass is 1.52. What do you mean by this statement? So now what we can write? The ratio of n is equal to C by V. The ratio of speed of light in air or vacuum to the speed of light of crown glass, medium and particularly we are taking medium as crown glass, is equal to 1.52. I think it's clear now. So this is about this table. Only they will pick up one medium and they'll give the refractive index. You have to define that statement. Only take the ratio of speed of light in vacuum to the ratio of speed of light in respective medium, and the refractive index will be mentioned. Just you say that. Okay, this is about refractive index. Next, here also we have two types of lenses, convex lens and concave lens. Reflection of light, we spoke about mirrors, concave mirror and convex mirror. The same name here also, convex lens, concave lens. So here what we can consider, it is a thicker in middle, thinner in edges. So how will be the convex lens? Thicker in middle, thinner in edges. The rays of this light parallel to the principal axis. Also what we can say, as it is a lens, the light will flow through that. So they will not reflect, they will refract. That means they bend ಆಗ್ತಿದೆಲ್ಲ. So light is flow. This will be like glass material. It looks like a glass material, this lens. So it's traveling from air to glass, so it bends, right? So they are converging at one point. So which is a converging lens? Convex lens. Which is a converging mirror? Concave mirror. Remember the reverse. Okay, so here light is converging at point, but if you consider concave lens, it is reverse. It is thinner at middle, thicker at edges, and here light rays diverges. They will not converge, they diverge. But ನಾವೇನು ಮಾಡ್ತೀವಿ, ಇಮ್ಯಾಜಿನರಿ ಆಗಿ ಇಲ್ಲಿ ಬರಬಹುದು ಅಂತ ಹಾಕೋತೀವಿ. ಸೊ ದೇ ಆರ್ ವರ್ಚುಯಲ್. I think I told about in this. So here two types of lenses, convex lens and concave lens. Convex lens is converging lens, concave lens is diverging lens. Convex lens is thicker in middle, thinner in edges. ನೋಡಿ ಇಲ್ಲಿ ಹೀಗೆ ಬರಿತೀವಿ, ಆ್ಯಕ್ಚುಲಿ ನಾವು ಇದನ್ನು ಹೀಗೆ ಬರಿತೀವಿ. ಸೊ thicker in middle, thinner in edges. But concave lens is, it is thinner in middle, thicker in edges, thinner in middle, thicker in edges, and it is diverging. Clear? So this is about lenses. Then if we move on to the next one, we have lens formula and magnification. Here also we have, as we have mirror formula and magnification, here also we have lens formula and magnification. Lens formula means there what we wrote, 1 by v plus 1 by u is equal to 1 by f, right? But here we are calling it as 1 by u minus 1 by u is equal to 1 by f. Yes, v is image distance, u is object distance, f is focal length. Okay, magnification, we have two types. One is we can consider in terms of height, another one we can consider in terms of the distances. So here the formula is 1 by v minus 1 by u is equal to 1 by f. So if it is minus, it is lens. If it is plus, it is mirror. Okay, here the image, this is similar to as mirror. So height of image by height of object. There also height of image by height of object. But in this case, if I consider in terms of distances, m is equal to minus v by u in mirror. But here you have only v by u. Don't confuse. If you consider plus in formula, that is mirror formula, it is plus. Lens formula, it is minus. But in magnification, if it consider minus v by u, it is mirror. Only the plus v by u, it is lens. Okay, but in terms of height, both are same. Height of image by height of object, both are same. Okay, so this is formula and magnification. Let's move on to the last concept in this, means theory concept. I'm talking about theory concept, that is power of lens. As you all know, if there are any defect in your eye, you are going to buy the lens, right? You buy the spectacles which consist of lens. Everybody asks what is your power of lens. Yes, right? They will ask, some will say 0.5 or minus 0.5, plus 0.5, minus 0.5, like this. So here basically what we tell about power of lens, what is the definition of power of lens, means it will take the reciprocal of focal length. If we consider the reciprocal of focal length, we are calling it as power of lens. Okay, power of lens is the reciprocal of its focal length, or P. We represent P is a power of lens is equal to 1 by f. The unit of power, diopter. Power of lens is diopter, but don't compare this with electricity lesson. Power means there we'll talk it about watt. Okay, here we call it as diopter, D. So power of lens is diopter. They may ask for 1 mark, right? The SI unit of power of lens. SI unit of power of lens is diopter. Now, if we define 1 diopter, if the power of lens whose focal length is 1 meter, yes, if I consider P is equal to 1, if focal length is 1 by 1, you will get 1 diopter. So, when we will get 1 diopter, power of lens whose focal length is 1 meter. If we consider focal length 1 meter, then power of lens becomes 1 diopter. So, this is about the diopter. Now, remember, if power of lens is positive, like plus points, definitely what the lens you are using, convex lens. Okay, if the power of lens is, for example, the power of lens is plus 0.5, what type of lens is used? So that is convex lens. Then the power of lens is negative. If the power of lens is negative, then it is concave lens. Then it is concave lens. I think it's clear. And this we have positive, negative, like this sign convention also I am going to explain when we are doing the problems. Okay, positive yavagagutte, negative yavagagutte, when we have to take a positive, when we have to take negative, like that I am going to explain when we are doing the problems. Okay, now just you remember, if the power is positive, it is convex lens. If power is negative, it is concave lens. Okay, this is all about the theory part of this lesson. Okay, in my next sessions I am going to explain you about the ray diagrams and also some numerical problems and sign convention. And in your textbook you have sign convention both in mirror as well as lesson. I am going to teach about that when we are doing the numerical problems. So if you like this video, do subscribe my channel, share with your friends and keep watching. Thank you.